We all don't want to use specific interfaces anymore. Industrial experts will discuss in the next couple of minutes how IPC-CFX can help to standardize interfaces. So, welcome to the show.
Welcome to the Facts on Open Automation show. A peaceful life is what everybody wants, also electronic manufacturers. And key ingredient for that is easy interfacing and interoperability. What if I tell you that there's a whole ecosystem of standards out there which you don't need to maintain or develop anymore? One example, IPC standard 2591, Connected Factory Exchange, CFX, is there to connect the different levels. And as mentioned, you don't need to develop anymore, and it's the last standard you will ever need to connect the different levels of your smart factory. But we need your help to push this standard because it's the clever thing, and that's what we are talking about. What is this standard? But we will also talk about cybercrime. So, as always, I have a group of qualified people to talk about all these topics. First of all, hello, Tamara Seitz.
Hello, Laszlo.
Tamara, who is IPC and why is IPC deciding upon a standard?
IPC is the Global Association for Electronics Manufacturing. IPC actually does not decide on the standard. It is the industry that decides on the standard as well as writes the standard. IPC actually oversees the writing of each standard, and we welcome everyone from every industry to participate with CFX.
Yeah, so everybody can contribute.
Absolutely.
Hello, Michael.
Hello.
To have you here. Michael, what is the situation out there in the electronics manufacturing industry? What should make every customer desperate for this standard?
Desperation for standards for communication. Having worked in the industry for many years creating machine interfaces, we're seeing a growing amount of confusion. It's very difficult to get information from machines, very difficult to understand what is the information, what format, what language, what method to get the data in, and it's causing a lot of frustration. But recently, of course, we hear about digital transformation and how there's this race to get to using the data to the most advantage to create value. And that has really stepped up the game for the need to get this data. But it's really proving to be difficult and expensive to be able to get the data in a form whereby it's usable to create value. And so that is what is really making people desperate, if you like, to find a solution to do that so that the focus can be on the value and not just in the how am I supposed to get this data.
Mm-hmm. So age of confusion, but also age of many possibilities.
Indeed.
Hello, Tom.
Hello, Laszlo.
So, Tom, why and how is ASMPT supporting this standard?
Well, ASMPT is supporting integration of our equipment for many, many years. In the beginning, directly on the equipment. Later on, we introduced a standard integration platform to facilitate work for us. But still, it's a lot of work on our side to write adapters to convert data, protocols, content. And it's also work on the side of our partners, software integrators. And with each new machine, a lot of this work is invalidated because new machine, new interface, different data. And so when CFX was introduced first time about 5 years ago, we decided to go for such a global standard. And 3 years ago, ASMPT took a strategic decision to move away from proprietary standards and go for a global standard like CFX. And as you mentioned, can CFX be the last interface to implement? We are convinced, yes, it can be. We need to push the industry to support it. And we believe that we then can get rid of all these superfluous efforts to just convert data. Instead of that, we can use our development power to focus on creating value, beneficial solutions for manufacturing. It's like traveling the world. I speak German as a native tongue. I can travel to several countries in the world. They understand me, people there. But many countries do not understand me. So speaking different language is always a hurdle for doing things together.
Absolutely. Michael, so this sentence, the last interface you will ever need to implement, so how is that the case?
It's a grand idea that we would only need this one interface, and you could imagine that CFX would take over, and be that standard interface for the whole industry. But let's just consider what that means, because it's really a value. Where we are spending a lot of time and effort, and of course money, to create middleware, it means that there is a financial burden to the industry. Having the CFX, if that CFX one single language can represent everything that we would like from manufacturing, so material information, quality information, what is the performance, are there counterfeit materials, all of those different aspects of production that we deal with every day, if they can be taken through one interface, the other interfaces are not needed. It doesn't mean we have to throw them away, other interfaces can exist, but it means that there is then this easier path to transfer this information, and therefore CFX would then become the last interface that anybody would ever need. That is great news, because once you've developed it once, that's it. The work has been done, the cost has been spent, and now we can just focus on the value.
Yeah, and I remember you mentioned it creates trust.
The trust in the data is a very important thing to create the value itself, because if the information is not complete, or it's not timely, or there is some inconsistency between different vendors giving the data, it means that even the charts that you make are not going to be accurate. Maybe in the past this could be tolerated, but today we want to promote automation within manufacturing using software that is going to make decisions. To be able to trust in those decisions, we need to trust in the data. With CFX, we are establishing a single language, a single way of talking, and so we can show that that data is trustworthy, can be relied upon, can be depended upon, and you can use it for so many different values, and you can automate your factory.
Absolutely. Tamara, IPC 2591 is plug and play, the implementation. Is that an exaggeration?
Thank you for this question, Laszlo. Plug and play means that once you have established your line and you have CFX within your first piece of equipment as well as your reporting feature, every piece of equipment thereafter would then truly be plug and play. Of course, you want to have qualified equipment. And when I speak of qualified equipment, which we'll touch base on again, is manufacturers or supply manufacturers that have tested their equipment through the IPC website portal to say that they have indeed all of the standard messages needed to be true plug and play.
I understand. So how many manufacturers are supporting IPC-CFX today?
Currently, there are over 100 manufacturers that support CFX. However, there are just under 30 manufacturers who have qualified equipment with around 60 pieces currently. However, we also have EMS manufacturers, which every manufacturer we please ask that support CFX and Industry 4.0 within your growth. But with those manufacturing partners that we have, there's roughly 27. And we also have several software manufacturers that are ready to help implement Industry 4.0 and CFX within the manufacturers' factories.
Thanks, Tamara.
Thank you.
One of the manufacturers supporting IPC-CFX is Viscom, a leading supplier of automated inspection systems. And I'm happy to ask Mr. Detlef Beer about his experience with IPC-CFX. Hello, Detlef.
Hello, Laszlo. Thanks for the invitation.
Detlef, you have recently installed 2 lines at the customer side where IPC Hermes and IPC-CFX is implemented. So what is your experience? What was the implementation like?
So from our part, it is at the beginning really that the company who wanted to use CFX has to take care about which messages they want to use. And here's really my recommendation that they should check the IPC recommendations here for each equipment. There's clearly defined which are useful messages for an AOI, for an SPI, for a pick-and-place machine, and so on. That is the first step. When this is clear, then in the second step, they should set up the ASMPT server. That is the heart of the system. And then in the next part, they should integrate it, then the status messages. So in this cases, that is quite an easy implementation. I think the John wrote 6 messages which have to implement. And then they already have the OE status of the systems, of the complete line, and have the first success for a first CFX use case. And then in the next step, they should integrate it, then the data output, especially then the testing results. And then they have their similar data they use commonly in an MES systems. And here it's interesting to check the line performance, the data transfer, because depending on the test results, you can integrate it or test just small data packages of 10 kilobytes, or you can set up the complete data which goes up into tens of megabytes.
What brings the combination Viscom and IPC-CFX to the customer?
So Viscom joined the CFX standard definitions from the beginning, and we already run here all the certifications to use these recommended messages from the IPC. So I think the main customer benefit here is really to have a faster setup in the line. And so that means really everybody is speaking the same language in the line. They don't have to adjust it any specification sheets, and we have not to use any customized software developments. And overall, it's also important that we have later on better ways to testing these interfaces, because when you have customized MES or implementations, that is always hard how you can test it this for any software updates. And with the CFX part, we have then our own ASMPT server. We can test it here completely offline and have then an easier and faster integration on customer side.
Thanks, Detlef, for sharing your experience with us. CFX is a standard. It is not a product of any manufacturer of software company. Is it free for the customer?
The software development kit, known as the SDK, is absolutely free. That is found online through the resources. You'll want to start by purchasing the standard from IPC, so you have all of the message capabilities. And of course, for the supply manufacturers, when they're qualifying their equipment, there is a nominal fee. But we'll want to start with the SDK.
Yes, the SDK is free of charge to download, together with a lot of information, online help about each single message and the data. And there's code snippets that help you to get started, and everything is free of charge. However, vendors may charge for the implementation because a data connection, as in the past, always requires some effort, and so vendors will charge for that.
Yeah, this is the traditional licensing model for software, whether it comes from a machine vendor or a software provider. There is always some kind of license, and that brings with it the provision of that feature and the support for it, etc. But when we say CFX is free of charge, we're talking about a cost which is much, much larger than that. Because as we heard earlier, the removal of the need for customization. The sheer cost of doing that with all of the NDAs that need to be in place, the software development, the testing, the follow-on support. We calculated that it runs into the tens of billions of euros if the whole world were to create smart factories without CFX. All of that cost is eliminated through the use of plug and play. And so that's the real message that we're conveying when we say CFX is free of charge. You've got the licensing fee as normal, but you've avoided all of that huge cost and risk associated with interfacing to many different vendors.
A huge amount. Another important question is, what are the key areas where manufacturers would gain benefit out of implementing IPC-CFX?
How long have we got? Mainly, CFX is about visibility, because instead of people going around using their skill and judgment to notice that something is happening, CFX is bringing that information to you, so that the human can start to say, I notice there's something wrong here, I see an opportunity for an improvement, I need to take an action to prevent something from happening. There are hundreds of different things that you would want to do with that. The nice thing about CFX is because of this very easy entry point, those kinds of ideas about what can we do with CFX, now you can say practically, yeah, I'd like to develop a little bit of software to do this. I'd like to create an AI to do that. I'd like to have this system talk to that system and understand together what's happening between materials, quality, and performance. Suddenly, all of those things are possible. So the real answer is visibility and opportunity, so that you can do so much with that data coming from manufacturing now.
Absolutely amazing. Thanks a lot. Let's see some use case examples prepared by my colleague Haitem Yaridi in our Center of Competence.
It's very important, of course, to integrate machines to the systems to be capable to use the software itself. We're using it by our Works, our shop floor software suite. And Works is providing dedicated solutions related to the workflows which you can support. And sometimes it comes to integrate third-party equipment. So instead of doing it by a specific interface, we are leading on IPC-CFX. And I selected some examples from related workflows, such as optimization, monitoring, and operation, to show you how easy it can be to first integrate IPC-CFX, and second, also use this data on a shop floor software suite such as Works. First example is related to the quality itself. So quality is, for example, something which we cannot detect or verify at the beginning of the line. So here the product is going to be produced, but most probably at the end of the line. What we did is we integrated AUI machines for the inspection into our systems, into our Works platform, to get all of this related information related to the defects and verification results. And we take this information and provide then, at the end of the day, a root cause analysis based on this information, sticking again on IPC-CFX. Next to, of course, any line information which are relevant to react on the process itself. And at the end of the day, we will, of course, be able to change or optimize parameters during the production itself, for example, at the printing or at the placement. Another example is showing us how we can monitor quality on the same monitoring tool where we can use also the information coming from a printer and placement, so for production processes itself. Here we have, for example, the yield. And yield is something, again, coming from the AOI, standing by IPC-CFX. Placement information and printing information will help me to get all of the rest of the KPIs, such as utilization or changeover time, component waste rate, or costs. All of this information are available on the monitoring tool next to the yield, which is also here linked to the AOI by IPC-CFX. And last but not least, another example where operator will be notified about any tasks which has to be done at the line itself. So here, the information will be collected by our operator guidance tool, be translated into a to-do list on the smart device, and an operator will get this information immediately to react in time. Whether it's an AOI or an OFN, all of this information are on the same device, standing from the same interface. To learn more about all of these integrations, just book a remote session. I'd love to show all of these use cases more in details.
Thanks, Haitem. At this point, a reminder, do not forget our customized free remote demonstration, which is for free, as I mentioned. And also don't forget to subscribe to our channel and give us a thumbs up, which is also for free. So, IPC-CFX, what's next for this standard?
Well, it's interesting to have a look at that, because we are evolving this standard as time goes on. And the kind of common functionality that probably 95–99% of people need is within that qualified level of CFX. But there are also some very interesting things that we are adding to promote new software technology within manufacturing. Thomas, would you like to give us one example?
Yeah, there are a lot of possible use cases, and very exciting use cases, process optimization. So CFX allows to retrieve all the data from printer, SPI, AOI to analyze the print process and then feedback corrective action to the placement machine and also to the printer itself to optimize the print process. Print process is #1 reason for failure of boards.
Another one we were looking into was energy management, very topical at the moment, because there are times when machines aren't needed to be working. And so it's nice to be able to not only measure the energy profile for any set of machine processes in conjunction with the product that's been made, but also to be able to remote control them to go into standby. You know, just like your laptop, put it to sleep, but make sure that it wakes up before the next product is needed. So all of that energy management to be able to reduce the cost of energy and be more environmentally friendly is also a new feature within CFX.
Another topic is maintenance. You can do it the stupid way. So, yeah, like your car in the past, every half year you do something. Maybe that's good enough. Maybe it's too late. Much better is get the data from the machine. CFX provides very detailed maintenance data, analyze it, and then do predictive maintenance or even do prescriptive maintenance. So do exactly what is needed when it's needed before the machine breaks.
So, you know, these are some examples of how we are making better analysis of information. And if we consider traceability as being one of the core values within manufacturing, understanding the relationship between materials and products so that we can have a better idea of supplier quality, effects of counterfeit migration, being able to really start to discover that source of defects so that we can head for zero defects. There is so much material and process traceability, all of the test results, all of the information that's been measured, it all comes through CFX. So people can start to put that together and make analytics on those patterns of data. So you can do that yourself. There are solutions out there to do it. It's, you know, opens your eyes to the whole world of digital manufacturing.
Amazing, yeah. But when we talk about data, as promised, we need also to talk about cyber crime, cyber security. And manufacturing became the #1 target for ransomware attackers. No wonder, because everybody implements the smart factory, but they also open up new possibilities for attackers through the Internet of Things. So is cyber security an even bigger argument for IPC-CFX?
Well, in today's day, security is a huge topic. However, the committee decided to use the AMQP protocol for the security within CFX.
AMQP, what is that?
The AMQP is the banking industry's security protocol. We trust the AMQP with our credit card purchases that we make via our mobile phones every day.
So a very tough.
Very secure, very secure.
Yeah, when it comes to data within manufacturing, it's ironic that we see opportunity to create value, but other people see opportunity to create value of another kind. The information that we have in manufacturing, it's about products, it's about manufacturing capabilities, delivery dates. That information is valuable to the outside world. And worse than that, people might want to put data into manufacturing to create issues. There was one case, there was a factory that when we went into and something wasn't right. You know, the machines, they were working, but something just felt odd and there were some delays here, and we discovered that the machines were mining for Bitcoin. So all of the computers in all of the different machines had been infected by some spyware that probably had come in through a local source. And just spread from machine to machine. And I don't know if they found any, but it was causing the machines to behave in an odd way because the processors were totally, you know, maxed out. And so we need to be very, very careful that, you know, this was an obvious case, but there are many other cases where we need to ensure the security and privacy of data that we have on our manufacturing network.
So IPC-CFX is secure, is the strong security.
It has encryption from end to end, so there is no way to actually intercept that data from a third party.
Let's talk about the ecosystem of standards, which I mentioned at the beginning. So IPC-CFX is part of this ecosystem. How is it with all the others in cooperation? How is the work? What does it perform?
Actually, IPC, the CFX, is the heart of the IPC factory of the future. It's surrounded by additional standards that will help you progress into Industry 4.0. This year, in 2023, we will have a training session that Michael, Thomas, and 8 others will host.
It's very interesting that we've always said that CFX is the enabler of Industry 4.0. But we need to take that a little bit further. So, okay, exactly how does that happen? And so by looking at the other standards, for example, design data, we're able to have a standard that represents the model of the product that we're making. What if we could deliver that data or make it accessible from the point of design through to the point of manufacturing? How would that work? Maybe also we would want to have the exchange of data between solutions. So we've been talking about CFX as exchanging data between machines. But what about these AIs that are working within the software environment? Perhaps they could communicate with each other and share data. So this is the whole creation of the digital twin, where we establish how can these applications exchange data, who owns the data, who has permissions to look at the data, how can we share information without risking loss of privacy and security. So all of those definitions are included in that standard. Plus we have standards that make a 3D component representation as standard. So you can model a product in 3 dimensions, including all of its components, and more and more and more. So we will discuss all of these different applications where CFX is the heart of the factory of the future in this upcoming event at APEX.
Absolutely amazing. Thanks a lot. And everybody needs to support this standard. So thanks for you all for explaining us IPC-CFX. I will have some final informations for you. If you want to see ASMPT live on events, so following events which you see down there in the ticker is where we will be live. Is there also events where IPC and the standard can be experienced live?
Well, we'll have the standard at APEX this January in 2023, Electronica in November, and then next year in Productronica, of course, and again at APEX.
Also, do not forget, as mentioned, the free remote demonstrations. Please also do not forget the free open automation white papers and IPC documents, which can be downloaded by clicking on the link in the description. Thank you for watching this show, for spending time with us, and thank you, Sri, for being with me.
Many thanks, Laszlo.
Thank you.
Thank you, Laszlo. Stay tuned and stay open, Laszlo.
So, that was a good discussion. And the cybercrime topic, I remember the story you mentioned about smart cars and that it's more difficult to hack them, so they hacked the factory.
Yeah, I had a look on YouTube just to see those examples of cars being driven into ditches, and you hear stories about people, your drivers being blackmailed, pay a certain number of bitcoins or your brakes will fail. And it's really frightening. But the thing is, the car makers, I mean, obviously, they've updated their security protocols, and so bad things like that, we hope, can't happen anymore. So what do the hackers do? They move upstream. Yeah. So if they can't hack the cars, let's hack manufacturing that makes the cars.
So open the door before.
Yeah, exactly. Put in a back door, maybe change the design, even changing the components we've seen so that it gives them access. Of course, change the software as well. So we've got to be so careful in manufacturing, to make sure that everything is as it was supposed to be.
It's a good thing that CFX is like superpowered with the AMQP.
Yeah, and the AMQP protocol has a clearly specified TCP/IP port for communication. So when administering a firewall to protect the machine, the equipment on the OT environment. You exactly know what to open and what need not be opened. And CFX is clearly specified content. So you know what can be communicated. And if you see something different on your firewall, you exactly know, okay, someone is tampering with your connection, and then you can stop it.
Yeah, so all of these older machines that we see people use, things that were created way before security became an issue, it's like a game of the weakest link, because the hackers search for that weakest link, get in there, and then all the other machines become infected from this one source. So if you have the security from CFX, as Tom explained, with that filtering, nothing can go anywhere. So you're protected against everything on the shop floor. It's a way of doing the firewalls for OT in the same way as IT have been doing the firewalling for the IT network. So it's a real game changer in terms of making sure that everything is secure, and now we can build our digital transformation without the fear of anything untoward happening.
And try to do the smart filtering with a whole bunch of protocols, every vendor with a different protocol. It will drive an IT administrator crazy.
You couldn't do it
at all.
And so actually a lot of companies, they've not been able to start digital transformation because they've insisted on an air gap. So no electrical connection between the OT network and the IT network. This filtering that Tom described breaks down that barrier. You don't need to have that gap anymore. And so it introduces smart manufacturing to a load of manufacturers that weren't ever able to do it before.
I see. We need to do a show on cybersecurity, an own show. It's a good topic.
Sounds good.
So, let's go to lunch, guys. Yeah.
Yeah.
Good.
Thanks.
Thanks.